Here is a casualty of war, a Tommy gun. It's been knocked out of action and is headed for the repair shop. This means there's one less weapon to use against the enemy until this gun is put in firing condition again. How long does it take to get it back into action? Well, that depends. If you know the gun thoroughly and understand how it functions, time can be cut to a minimum. And that's the important factor when you're doing your job in the field. So let's see what makes it tick. The Thompson submachine gun, caliber 45, model 1928 A1, is air-cooled and blowback operated. It can be fired either full automatic or semi-automatic. The gun is simple, light, flexible, and its high firepower makes it very effective at short ranges. It's a reliable friend in a tough spot. In order to have a clearer picture of how the Tommy gun functions, we'll cut away the side of the receiver and frame so we can see what the inside looks like. To simplify our explanation of functioning, we'll divide the firing cycle into 3 phases. First, the trigger movement. This involves the trigger, the disconnector, the sear lever, and the sear. And now the second phase, the forward movement of recoiling parts. This involves the receiver group, the bolt group, the recoil spring, finally the third phase, the rearward movement of recoiling parts, which also involves the receiver and bolt groups and the recoil spring. To load, the bolt is drawn to the rear, the safety is locked, and the magazine inserted. To fire, unlock the safety, and here we are ready to take up the first phase of functioning, the action of the trigger mechanism. We'll use an animated diagram and take it step by step. Notice that the forward part of the bolt has been cut out to show the hammer. Now watch the action of the trigger mechanism. When you pull the trigger, it turns on the trigger pivot. This lifts the disconnector up under the sear lever, which in turn pushes up the front end of the sear. The sear rotates around its pivot and depresses the nose of the sear. This lets the bolt go forward. Now, let's follow these steps on the gun itself. We're looking at the top of the frame. It's removed from the receiver. We'll slow up the action and take it step by step again. The trigger is pulled, it rotates on its pivot, and lifts the disconnector up under the sear lever. As the sear lever rises, it lifts the front end of the sear. At the same time, the sear is rotating around its pivot, and the nose of the sear is being depressed, allowing the bolt to move forward. This brings us to the second phase, the forward movement of recoiling parts. After the bolt has traveled about an inch, it strikes the cartridge, which is held under the lip of the magazine. It pushes the cartridge forward, up the bullet ramp, and into the chamber. Here's the same action on the gun from the right-hand side. The front end of the bolt strikes the cartridge and pushes it forward. The cartridge is held straight until it has almost cleared the magazine. The bullet ramp then guides it into the chamber. When it's seated in the chamber, the extractor snaps around the groove of the cartridge. During the forward movement of the bolt, the lock is cammed down into the locking grooves of the receiver. This occurs just before the bolt reaches its extreme forward position. The triangular-shaped hammer is located on the underside of the bolt. The lower point of the triangle strikes the front end of the receiver as the bolt travels forward. The hammer pivots, driving the firing pin into the primer of the cartridge and firing the round. This brings us to the third and last phase of the firing cycle, the rearward movement of the recoiling parts. Here is our diagram again. When the cartridge is fired, its fast-burning powder produces maximum chamber pressure almost instantaneously. This pressure drives the bolt back. The bolt, in turn, forces the lock back against the locking surfaces of the receiver. Now back to the real gun again. Notice the angle of the locking groove. You can see how the rearward pressure of the powder gases forces the lock back against these grooves. That's how the bolt is locked in the forward position. The receiver of this weapon is made of steel. The lock is made of bronze. The reason for this is the two metals tend to stick together, helping to keep the bolt locked long enough for the projectile to start on its way out of the barrel. As the projectile leaves the barrel, the high chamber pressure is reduced. This releases the pressure on the lock, allowing it to move up and to clear the locking surfaces of the receiver. The bolt can now move to the rear. After the bolt has been unlocked, the remaining gas pressure drives the bolt to the rear, compressing the recoil spring, which cushions the shock of recoil and stores up power for the forward movement. Let's go back to the diagram again. Notice that we're on the left side of the gun. Now, as the bolt moves back, the firing pin spring forces the firing pin away from the face of the bolt. It also makes the hammer pivot around the hammer pin, cocking the firing pin. As the bolt moves to the rear, the empty cartridge case is withdrawn from the chamber by the extractor, which is snapped around the groove of the cartridge. The extractor holds the empty case on the face of the bolt until it hits the ejector, which causes it to pivot and fly out through the opening. Here is the same action on the gun in slow motion. Watch the empty case pivot to the right and out when it hits the ejector. As soon as the bolt with the empty cartridge case has passed over the lips of the magazine, a fresh cartridge is forced up into firing position by the action of the magazine spring. There are two notches on the underside of the bolt. The front sear notch and the rear sear notch. The sear may engage in either the front or rear sear notch, depending on the force of the bolt's rearward movement. When the submachine gun is fired, semi-automatic, it fires a single shot with each pull of the trigger. When it is fired full automatic, it produces bursts of shots with each pull of the trigger. semi-automatic and full automatic action is controlled by the rocker and the rocker pivot. To demonstrate, we'll place the receiver and frame side by side. The parts are in the same relative position as in the assembled gun. In semi-automatic fire, the rocker travels in the T-groove on the underside of the bolt. When the point of the rocker reaches the end of the T-groove, it's forced forward, bringing the rocker's rounded part in contact with the disconnector. Thus, the disconnector is forced out from under the sear lever. The sear lever operates independently of the sear, blocking the disconnector when the bolt moves to the rear. As soon as the sear notch is exposed, the sear spring expands, forcing the sear up to engage the bolt. Contact between the trigger and the sear is reestablished when the trigger is released. The trigger spring expands, pivoting the trigger so that the disconnector is lowered. The disconnector spring then expands and forces the disconnector to return to its position under the sear lever. Notice the rocker is thus returned to its upright position. With the rocker pivot in this position, the Tommy gun will fire at the rate of about 600 rounds per minute. It takes 5 seconds to empty a 50-round drum magazine. The rocker pivot is of eccentric design. At full automatic, the rocker is low enough to allow the bolt to move forward without striking the point of the rocker. Therefore, the sear nose remains in its lowered position, and the gun fires as long as the trigger is held, or until the cartridges are expended. Now for the safety. It works like this. When the safety is turned toward the rear or safe position, the rounded part of the safety fits into a groove on the sear and locks it in its uppermost position. When it is set at fire, the flat milled surface is in a position where the sear can rotate around its pivot. Remember that the safety cannot be turned when the bolt is forward. The bolt has to be to the rear because the sear must be up in order to allow the rounded part of the safety to engage in the groove of the sear. Also remember that when the bolt is forward, the drum-type magazine cannot be inserted or removed. You can clearly see that when the bolt is forward, the front part blocks the path of the magazine. Now we'll draw the bolt back. Notice that the front part of the bolt is no longer in the way, and the magazine can now slide in freely. Now for the trip. Here it is. The trip functions only when the box-type magazine is used. Its purpose is to hold the bolt open when the magazine is empty, therefore saving time when changing magazines and increasing the firepower of the weapon. When the last round is fired from the box-type magazine, notice that the bolt stays open. That's the function of the trip. Here's how it works. There's a fin on the back of the magazine follower. As the magazine empties, this fin rises up, and when the last cartridge is pushed out of the magazine, the fin strikes the trip. When the trip rotates around the trigger pivot, it pivots the disconnector, which compresses the disconnector spring and holds the disconnector forward of the sear lever. This leaves the sear free to rotate. As the bolt passes to the rear, the nose of the sear is forced up by the sear spring and engages a sear notch on the bolt. This is what the fin looks like on the rear magazine follower. Remember that the trip works only when the box-type magazine is used. When the last cartridge is fired from the drum magazine, the bolt will stay closed. Now for a brief review of some of the highlights. Functioning breaks down into three main parts: the trigger action, the forward movement of the recoiling parts, and the rearward movement of the recoiling parts. Now, watch the complete firing cycle. The trigger is pulled, turning on its pivot. The disconnector is raised, which in turn raises the forward part of the sear and sear lever, depressing the nose of the sear and allowing the bolt to move forward under tension of the recoil spring. The bolt strips a cartridge from the magazine. The cartridge is guided up the bullet ramp and loaded into the chamber. The lock is cammed down into the locking recess of the receiver. At approximately the same time, the lower part of the hammer strikes the forward part of the receiver, rotates, and strikes the firing pin. The firing pin is forced forward, which in turn strikes the primer of the cartridge and ignites the powder charge. Pressure from the expanding gases is transmitted through the cartridge case, bolt, and lock against the locking recesses in the receiver. As the bullet leaves the barrel, the pressure subsides, releasing the lock. This action retards unlocking. As recoil starts, the firing pin spring forces the firing pin to the rear and rotates the hammer to its original position. This action withdraws the firing pin from the face of the bolt. As the bolt continues to the rear, the ejector strikes the base of the empty cartridge case, pries it from the grip of the extractor, and throws it out of the ejector opening. The next cartridge is forced up into loading position by the magazine spring. When the eccentric rocker pivot is turned to the single fire position, the rocker is raised in the path of the bolt. The rear of the T-slot strikes the rocker, forces it forward, forcing the disconnector out from under the sear lever. The sear lever operates independently of the sear, blocking the disconnector. When a sear notch is exposed during the bolt's rearward movement, the sear spring expands, forcing the sear up to engage the bolt. When the rocker pivot is turned to the automatic position, the rocker is lowered away from the path of the bolt. The sear nose will remain depressed as long as the trigger is held to the rear. The bolt will move back and forth, firing the weapon until the ammunition is expended or the trigger is released. With the bolt to the rear, the safety can be turned from the firing position to the safe position, locking the sear. The purpose of the trip is to hold the bolt to the rear after the last cartridge has been fired, firing automatic from the box-type magazine. When the last cartridge has been fired, a projecting fin on the follower rises, rotating the trip. This pulls the disconnector out from under the sear lever. With the disconnector in this position, the sear is free to engage one of the sear notches in the bolt. Well, that's the story of how the Thompson submachine gun functions. With a clear picture of what makes it tick, plus skill and practice, you can make sure that the Tommy gun will not fail when it's needed most.